Okay, so welcome today to this session. Okay, so today we are here to talk about PassivHaus as part of the Bass Coast Sustainability Festival. So I am actually the coordinator of Totally Renewable Phillip Island, and the theme of this festival is Future Homes and Farms for 2040. Empowering people to adapt. So I think it's very relevant that we talk about PassivHaus within this context as well. So before we go any further, however, I would like to pay our respects to the First Nations people of Australia and acknowledge the Bunurong and our neighbours, the Gunai-Kurnai, as the true owners and custodians of the land. And it is actually these lands that we're striving to protect and renew. So I feel a very in-depth relationship to being part of everything around me. And that's actually part of the premise of a lot of what I'll be talking about today in terms of a local context for PassivHaus, the Architects Declare movement, which is focused on setting humans as part of and in balance with a broader ecological system. So what is Totally Renewable Phillip Island? So we're basically a collection of groups and individuals who are passionate about changing for a positive future. And we believe we are all in it together. And our specific mission is to be carbon neutral by 2030. And obviously that's got some very broad ramifications in terms of how we get to that. It's not just a matter of mathematics and accounting. There's so many factors involved. So TRPI has currently 15 member groups and organisations, which you can see at the top of the diagram. And then at the bottom of the diagram, you can see there's 6 working groups. So education, energy, transport, food and waste, carbon farming, and carbon accounting. So TRPI's been working since 2018 with a big public meeting towards our mission of carbon neutral by 2030. We've had seed funding from the local council, so we've been absolutely fortunate to have their support. And incidentally, we've got the same goals and deadline of 2030 to take action locally. So I commend the council for their climate change action plan, which has net zero emissions by 2030. That's phenomenal. We are looking to take as many people on this journey with us as possible. So we're very keen to talk to other communities in Bass Coast, particularly the waterline communities. And we'll actually be hanging out in Coronella, Coronet Bay and Cowes over the next 2 weeks for some casual coffee chats. So we welcome everyone to come along. So now we're up to what we're talking about today. So what is PassivHaus or PassivHaus? And potentially there could be some people here today who think PassivHaus is passive solar design, which is completely understandable because it's very confusing terminology. But passive solar design is basically good principles in designing houses. So you face towards the sun, you take in human psychology, shading, landscape, all that sort of thing. So that's fantastic. That's been around since 70s at least, and it forms the premise of what we do as architects. And this is probably where I should admit I am an architect and a certified PassivHaus designer. So PassivHaus itself, or PassivHaus, which makes it sound more official, is a German standard that started in, I think, 1991 in Darmstadt in Germany. And it's a very rigorous way of testing houses, or buildings, I should say. And it creates very energy efficient buildings. So PassivHaus, briefly, I guess, as an overview. So the standard is about insulated, efficient, comfortable and ventilated buildings. They allow for energy savings of up to 90% compared with typical existing buildings. Okay, we've got a friend with us now. And compared with, so that's compared with typical existing buildings and even new best practice constructions, it's still a energy saving of over 75%. So the good thing about PassivHaus buildings is that when they're a certified PassivHaus building, they're tested and measured after construction to get an actual performance. I'm calling it a leaky air rate figure. So most other systems like the NatHERS STAR system It's never verified. So there have been studies that show what we think is a 7-star home, when it's tested, actually performs as a 2-star home. So it really comes down to the rigor with which something is built, and that it is built well to a high standard of construction. And I just like to think the question always is, when you're doing something non-typical, such as demanding a higher quality of construction, the assumption is it's going to cost more. And yes, it will cost more. It's estimated passive house construction is between 5 and 15% more expensive than typical, I guess, construction. However, if you start thinking in a life cycle perspective, so over the lifespan of 20 years, if you're saving 90% less in energy bills every year versus that additional input, you're basically putting quality first and making savings along the line. And that's something we find, I have found over the years in architecture in Australia particularly, is understanding it's worth putting more in upfront and thinking it through, which is something specific that architects like to do a lot of. So what I will do in a second is play this video. Hopefully I've ticked the right button. Let me just check. We'll see. But so essentially, passive house, what is it like being in a passive house building? It's very quiet inside, and the temperature is comfortable and constant everywhere, all the time. The indoor air quality is outstanding thanks to a continuous supply of filtered fresh air. So that's good for everyone, but especially for occupants with respiratory issues like asthma, or those who suffer from seasonal hay fever. And we find more and more that there, as we encounter things like thunderstorm asthma events, bushfire smoke, haze, all this kind of thing, there is more and more need to have control over the quality of building air that we breathe as humans. Another thing worth noting is that a certified passive house building uses no more than 15 kilowatt hours per square metre of the floor space per year for heating and cooling, which is quite phenomenal. So a lot of these, I've deliberately used a lot of existing and accessible resources in this discussion. I don't want to get too technical. So a lot of these photos I have taken come from this amazing book, Passive House in Australia, which I think was released last year and written by a good friend of mine, who's now on the board of the Australian Passive House Association, AFA. So let's see if this video will work. Let's have a go. Can you hear that? Sorry. Okay, so I don't know if everyone could hear that or not, but if not, it is on YouTube. So I think as a pictogram, it probably was mostly self-explanatory, but feel free to go and check that out as well. I think I've actually put it up as a playlist in the TRPI website as well. Sorry, the TRPI YouTube channel, which is under development. So if we come back to the idea that passive house is insulated, efficient, comfortable, ventilated buildings. Sorry, just letting someone in. Here we go. So what is it like to live in a passive house? So I won't read through this, but essentially the notion that passive house buildings also provide a major opportunity to reduce your carbon footprint. So if we take this back to the notion of TRPI's target of being carbon neutral by 2030, I think better quality buildings that require less energy consumption to run comfortably are quite critical. And that's where my interest, I guess, in passive house is. Now, this again is out of that Passive House book that was published last year for the Australian context. And this is actually a very local project, Monash University. And it's actually by the architects were Jackson Clements Burrows, who are actually the ones doing our Cows Cultural and Heritage Centre, which is also intended, I believe it's been designed as a passive house building. And I just wanted to read a little bit about why Monash Uni thought it was important and what their findings from doing this amazing, I think it's the student accommodation. So I know it will be hard to read for you guys, so I'm just going to read a little bit out now. So basically, the design parameters improve the building's ability to provide comfortable living conditions without energy-hungry mechanical heating and cooling systems. So the good thing about this is they've also used rooftop photovoltaics or solar system to dramatically reduce the student hall's reliance on the electricity grid. So that's very interesting as well. But I guess I'd just like to point out here, room temperatures remain consistently at 20 to 25 degrees Celsius with no added heating or cooling. So we're talking about a very stable environment. So that's no heating or cooling, just passive. And this is where we get the idea of passive house. It's constant. So the building showcases the university's commitment to both first-class student accommodation and achieving net zero operational emissions. So this is Monash Uni who have done this, and they invested quite a bit of time into this model, but I actually listened to a talk that they did, and it was quite phenomenal that the students' energy heat alone could maintain stable conditions. And they actually found a lot of students were bringing in their own mini heaters, presuming it would get cold, and that was actually throwing the balance of the building out. So they actually had to do some education programs to let people know they didn't need any additional heating or cooling, which is quite phenomenal. So just having a quick look at the 5 key design principles to understand a bit more what they are. And we can see we're talking Germany because we've got some German words here. Incidentally, my name is Zoe Geyer, but I do not speak any German, maybe a few generations back. So these are the 5 key principles. So air tightness, thermal insulation, mechanical ventilation, heat recovery, and high performance windows and thermal bridge-free construction. So I'm just going to talk a little bit, and again, this is a beautiful local diagram. This is actually from that book as well, and this is Talina Edwards' architecture. She's actually done a passive house called Our Woods, which has been in the media a lot lately. So this example is actually drawn from a real life project here. So looking first at air tightness, what are we talking about with air tightness? So when certified, passive house buildings are tested and measured after construction. So the measure is air changes per hour, or ACH. So this is really measuring how many times every hour the entire inside air of the house can leak out, or vice versa. So there is the maximum leakage you're allowed to have in passive house is 0.6 air changes per hour, i.e. every hour it doesn't even leak out once. And that's the maximum. So a lot of passive houses achieve well under that as well. Interestingly, to compare this, in 2016, the CSIRO measured the Australian average leakage of new houses as 15.4 air changes per hour. So each hour, the entire inside air leaks out just over 15 times. So we compare that to passive house, which is less than once, and probably on average half the air leakage every hour, because quite often they're down to 0.2, 0.4 air changes per hour. And then so basically our typical Australian house, you know, over 15 times an hour. So I like to think of this as a nice, warm, comfortable inside air temperature having to be completely reheated every 4 minutes to stay constant. So if you think of that and the use of energy required to create a comfortable, stable air temperature inside, it's quite mind-boggling. And this is part of that CSIRO study. These are different cities around Australia. And this is the national average here. Oh, I gave them a bit more credit. It's 15.5. And all of this, again, these studies are available online if you'd like to check any of those. And you might say, how does this impact us as well? So we all know it's expensive to run, heating and cooling, power prices. This is on the AFA, the Australian Passive House Association website. They've actually got an interactive, what do we call it? Table to measure the performance gap. They've compared PassivHaus with a 7-star NatHERS rated building, which is fairly high. NatHERS only goes up to 10-star at the moment. So it starts at 6, goes up to 10. And basically, if you build to PassivHaus, these are what can be achieved over a 7-star NatHERS rated building. So potential savings up to $5,000 a year. So thermal insulation. So basically PassivHaus has to be a fully sealed envelope. So the insulation isn't just in the roof or the walls or the floor, but it's actually all around. It's a continuous insulation, including up to and around windows and doors, around footings, all of that sort of thing. So it's completely sealed. And there is an analogy, sort of like an esky. You know, if you puncture a few holes in an esky, all the air is going to go out and it's not really going to perform anymore. And these are just some examples. There is a group called Builders Declare, which was actually supported by Architects Declare, of which I'm a signatory, and formed, I think, last year. So it's all quite, there's a lot of change in the construction industry at the moment, which is fantastic. Glux Builders are a local builder as well, who are part of Builders Declare. And I think this image here is taken from Michael Lim Construction, again in Melbourne. So this is showing part of the build-up system that stops some of the heat transfer inside and out. So you always batten off cladding. Anyway, I won't get too technical, but the nice thing to know, Builders Declare is doing great things, like they're talking about the war on construction waste as well. So these are from Instagram. Feel free to have a little look if you'd like to see a bit more about what some of the guys on the ground are actually doing. So here we are talking about mechanical ventilation heat recovery, or MVHR. So again, this is out of the PassivHaus book. So mechanical ventilation, it's a clever heat exchange system that can recover up to 95% of the energy in the stale air being expelled. So that then is used to warm the incoming air if it's cold and cool it if it's hot. So basically it's a very efficient system. So there's a bit of cost in these systems, but again, that's upfront cost and they more than pay for themselves. So you can see down here, it's typically the size of a clothes dryer, is often installed in a cupboard in the laundry or hallway. It's very quiet and it uses less energy than a 50-watt halogen light bulb.
What is the typical cost for the average house, if there is such a thing?
Look, I believe they're around $10,000 to $15,000. But again, if you put in hydronic in-slab heating, you're talking $14,000 anyway. So we spend a lot of money on the energy systems we put in to heat or cool buildings. But if we spend a bit more time and energy in actually creating a better quality of construction system, then we don't need that investment in heating and cooling. And the other, that's probably a really good point, Bernie, because the other benefit of these systems is they deliver fresh air. So it's filtered of dust, pollen, and other pollutants. And it extracts stale, moist air. So it also balances carbon dioxide levels. And there's a lot of information in the book about studies on the effectiveness in office buildings of workers. I think there was something about 61% improvement in their performance once the air was balanced and they had fresh oxygenated air at the prime levels. But what I'm particularly interested in, because I've been looking a lot about climate adaptation and resilience of buildings for future climate conditions, I'm particularly interested in, you can actually get specialist filters for these systems that will remove even small particulate matter, such as is found in bushfire haze. So again, I know there's also, what are they called? Is it Doctors for Climate? I heard them speak in what year was that? 2019 at the Melbourne Town Hall. And they had some amazing health statistics on basically health conditions that can be attributed to climate change as well. And they're pushing for a lot of death certificates to actually be written down as climate change as the cause. So a lot of air quality issues, a lot of mold in houses, a lot of these things that contribute to poor health in humans can actually be resolved again through systems such as PassivHaus. By the way, I just mentioned I'm not trying to sell PassivHaus. I'm really just trying to explain the benefits, because you can achieve amazing outcomes using other systems as well. But this is a particular system that is very energy efficient. So high performance windows. So basically, this is a local crew in Melbourne, I think, Bink Windows. So they are one of the first local manufacturers who've actually produced a PassivHaus compliant window system. So what makes them different? So basically, we're looking at thermally efficient frames, double glazing as a standard with triple glazing options. There's specific, you can see up here, or you may not be able to see, but they mention this particular series here achieves U values as low as 1.1 and SHGCs as low as 0.258. So what we're talking with U values is how well a window prevents heat from passing through. SHGC is a solar heat gain coefficient. I'm sounding like an architect now, or how much solar radiation passes through the window. So we're talking about heat and light effectively. So PassivHaus windows have requirements of minimums. And I should mention there's the PHPP, which is a 40-page Excel data sheet that you fill out when you're testing a building for PassivHaus compliance. And you basically will put in specifics of every single window type, every single wall composition and build up, insulation and everything. And it all is part of a very balanced and measured system that at the end of the day gets you that outcome of how many air changes per hour the building will have. And I think this may be the final element of the principle. So this is thermal bridge free construction. So what is a thermal bridge? You can read that if you like. But this is my interpretation. So basically a thermal bridge is a weak point in the construction where heat or cold, so temperature change, can travel more easily from the inside to the outside. And why we don't like that is if you think of a metal spoon in your cup of tea, you go to pick up that spoon and it's hot. So that is a thermal bridge. It's conducting the heat from inside the tea to your hand. So what we don't like in PassivHaus is heat traveling from inside to outside, because that's where we lose temperature, and we're talking about a stable environment. So I won't go through this, and this is not necessarily PassivHaus, but it is talking about thermal bridging. So you can see two wall build-ups inside to outside. We've got some cladding here. And it's talking about our wall system actually conducts heat as well. And this is showing one way of putting a thermal bridge in. So again, it's a very specific approach to construction. You can retrofit buildings, but it is quite complex, but the standards are more forgiving in PassivHaus because they understand it's harder to achieve the specific requirements when you're working with something existing. So you might say, what difference does any of this make? So an example I've been told by a builder and an educator in the PassivHaus program was a typical Australian house leaks air to the equivalent of leaving a whole door open all day long, day and night. Whereas with all of those 5 considerations, the key principles of PassivHaus and the testing to 0.6 air changes per hour, PassivHaus leaks equivalent to the size of a credit card. So if you think of a credit card versus a whole door open, that's a lot of difference in stability of air temperature, or the Australian thing of shut the door. Did you grow up in a tent? So I just want to say, let's have a quick look, and I promise it will be quick, at some of the bigger impacts of efficiency in our houses. And I am speaking houses here specifically, but PassivHaus is actually a building system, not just a house system. So houses in Australia are getting bigger and there are less people in them. So in 1911 in Australia, there were on average 4.5 people in a house. In 2016, it was about 2.5. In 2017, Australia had the largest houses in the world, shall we say, or all the countries surveyed, and we just pipped the US to the post. And if you think of that size as a volume or a space, it's a lot of space to heat, leaking out every 4 minutes. So PassivHaus buildings, again, if you consider that they allow for energy savings up to 90% compared with typical existing buildings, over 75% compared with best practice new construction. So if we are going to build these enormous buildings, for whatever reason we're doing that, at least if we start looking at better standards like PassivHaus, we can reduce some of that, I guess, the wasteful energy use required to heat these huge buildings. So yeah, we're living in larger houses with more internalised space and less humans. So throw in housing affordability and it is a perfect storm. So broader context again, so 2017, the Victorian Climate Change Act came in. The Victorian government released Victoria's climate change strategy this year in May, with a target of net zero emissions by 2050. So this is that there. I won't go through that again. This is all available online. But I think it is worth noting that the government is supporting households to reduce emissions and save money. So if we think about that and we think about requiring less ongoing costs to run a building, especially if we think of affordable housing or people on low income who inherit these buildings and then just have to pay the cost of heating them, it's not really a great direction that we're currently headed in. Again, this is just an excerpt from Builders Declare Instagram. So very recently, Builders Declare, Architects Declare, a lot of other people were putting in applications in terms of the new construction code, which is being released for 2022, we hope. We're currently working off a very outdated National Construction Code, which has very low requirements for energy efficiency and construction quality. So again, this is just a little snippet of, I guess, what's coming out. So say goodbye to the 6-star relic. Codes are set to change, not only lifting to 7 stars, but also incorporating appliance use and photovoltaics in the march towards zero carbon housing. So unfortunately, it's not coming fast enough, but at least there is change. Now, again, out of the PassivHaus book, so buildings produce 40% of Australia's total greenhouse gas emissions. 23% of that is basically the energy used to heat and cool buildings. And then there's also embodied carbon in building materials and supply chain emissions, such as, you know, delivery of materials by trucks, etc., etc. So more locally, in 2019, the Bass Coast Shire declared a climate emergency. Thank you, our Mayor, Brett Tessari. And in August this year, the draft Climate Change Action Plan was actually endorsed by our councillors. Fantastic. And our target in this Shire is net zero emissions by 2030, which is fantastic. And again, this equates with TRPI's goal of carbon neutral by 2030. So we're on the same path and we're working together to try and get there. So fantastic information available online on the Bass Coast Shire website. For basically, they have tested and monitored and assessed all of the existing outputs, and they have an action plan to get to 2030 and how we're going to get there, which is fantastic again. So again, just a snippet from that report. So you can actually see this is a chart showing our current use of energy. So stationary energy, transport, agriculture, waste and wastewater, industrial processes and product use, land use, change use, and forestry. So you can see this one's a negative, which means it's actually taking carbon out. These are all contributing carbon. We actually had a presentation, I think last week, about a 101 about carbon and why we don't like it, or as Tim pointed out, we do like it because carbon makes up most living things, but we like it in balance. So essentially the greenhouse gas emissions in the Bass Coast are about 18.6 tonnes of carbon dioxide equivalent per person every year. So the total emissions for the region, about 675,000 tonnes. The largest sector by far is stationary energy, which is about 39.8%. So again, that equates very much with that PassivHaus assessment that buildings are about 40% of carbon emissions. So stationary energy includes electricity, LPG bottled gas, mains gas, and firewood. So this actually figure accounts for renewable energy already happening. So it shows we've got to basically do even better. So I would like to say this is just one cost of our big inefficient buildings. So that's a lot of me talking. And it's really just trying to get a snapshot again, nothing too technical. But I do believe we have lots to do. Luckily, there's a lot of us on the same path and a lot of people really keen for change, and really we just need to facilitate it and make it easy, and that's part of what TRPI is trying to do. We're trying to share information and make things available through connections and partnerships. Thanks for coming along today. We will be around for chats, as I said, Coronet Bay, Coronella and Cows. But now I'd like to basically come back to Q&A if we have any questions, and I'll do my best to answer anything about the technicalities.
I did, Zoe. Thank you.
Not at all.
As with the prezos from yesterday, is this prezzo available for us to look at as a replay?
Yeah, definitely. I hope. I'll just check. Yes, I am recording it. So that will come up on the TRPI YouTube channel. I put one session up there. It wasn't actually part of the festival, but Mary, who's on the call today, actually ran a great session on a second-hand electric vehicle bulk buy option. So that's already up on the YouTube channel. But yes, it will be.
Perfect. Thank you.
Now, I think in the chat, Mary's asked, can you speak about retrofitting buildings? Is this possible with PassivHaus? And yes, it is possible. PassivHaus has a few different standards. I wish I had, oh, here I do have it. And they all go from basically the standard PassivHaus through to basically a house that is completely energy neutral. In other words, it generates as much renewable energy as it requires. But then the higher standard, and I forget the names, I think it's PassivHaus Plus, maybe there's one higher, where basically it produces in excess of its own needs and contributes back for other people to share that energy. And that's similar to the Living Building Challenge ideals, if anybody's familiar with that. But there is another, oh, here we go, PassivHaus Classic, PassivHaus Plus and PassivHaus Premium. Then there's also, for retrofitting existing buildings, there's a standard called ENERPHIT, so E-N-E-R, capital P-H-I-T. So it's a slightly less stringent requirement compared to PassivHaus in recognition of the logistical challenges of retrofitting older buildings. So one of the issues in retrofitting, and something a lot of us do where we think, oh, well, we'll change our windows over and we'll upgrade, and that will help our house. You know, that will, I think the problem is if you look at a house from a purely building technology level, and I used to tutor building tech at RMIT and Monash Uni, there's a lot of factors at play. And if you look at the 40-page PHPP requirements for PassivHaus to make sure the house performs as its own sort of ecological system, there's things like the level that heat is balanced between your head and your feet. There's corners that can attract moisture with the thermal bridging potential that can lead to mold growth. So there's a lot of very technical things that if you just swap your windows over in your house, it might actually cause an imbalance that could increase, you know, water logging or moisture or the growth of mold and this kind of thing. So I think that's where it can be dangerous when we just bit by bit make changes to our houses without a collective overview. And it's something, it's very challenging, shall we say.
Zoe, could I follow that question on then about that? Because the retrofitting is obviously going to be a very big need, particularly with climate change, and particularly for a lot of older existing houses. So is there, you're talking about new standards coming in, is there, do you see a balance coming where that it'll be much more acceptable, like a higher level of standards for towards PassivHaus, as in, you know, a better type of building? Do you see that is possible? Is that and what are governments and what are you know, what's the go? Maybe we could speak to Simon or, about this, about where are councils, not necessarily our council, but where are councils at in considering these changes in standards?
Well, I know there's been a lot of lobbying from builders and architects and pretty much everyone else, most likely planners and all sorts of people, to try and get better quality standards. I think we're still working off the 2016 National Construction Code, which really, I also was in a talk from a consultant who basically compared the standards and really the requirements on a chart that he showed were pretty much below anything else in the world and really didn't take into account anything to do with energy use or even the health of buildings as a very complex balanced system. And I think we often don't understand until you start to design and consider a building how complex they are. I mean, we produce 80-page documents just with a specification. If you start to throw in things like looking at supply chain information for things like cladding materials. So Paul Haar, who was involved in the launch event for the Sustainability Festival, he's doing amazing things in this space. There's a development called the Paddock, which he was part of. I think it's the Paddock, actually, I'm getting a few confused up, but I think it was the Paddock. And basically as part of that, they did a whole lot of open source information, just looking at which timbers were okay and not okay in a sustainable sense. So where they were sourced from, how they were, you know, treated, what off-gassing they had. There's just so much complexity in everything and so much research involved. So I'm sorry, I'm going off on a tangent, Mary, but I just want to say it's very complex when you want to start to do the right thing sustainability-wise. And I remember my grade 9 geography teacher giving me a photocopied handout of whose problem is it that we're, you know, cutting down rainforests in Malaysia. And the answer was basically at the end of the day, people like me who specify those products, and we're kicking off a chain of supply that has impacts elsewhere in the world. So I think that responsibility and the knowledge of products is essential. But in terms of adoption of better quality buildings, we are seeing a lot of uptake. I mean, the very fact that the Cowes Cultural Centre is, I believe, and correct me if I'm wrong, Simon, I believe it's a PassivHaus design. And I believe from discussions that council is very interested in adopting a lot more passive house projects locally. Again, passive house is probably the extreme of extremes for efficient, well-balanced, healthy, comfortable construction, because it takes into account everything from the health of the occupant, comfortable air temperature, you know, lack of heating requirement. It doesn't allow for mold growth or building conditions like that that are detrimental to our health. But you can still achieve a lot without going to that passive house level. But again, it's that question of balancing your choice. So if you spend that extra, you know, 10, 15% up front and you're saving 90% of your operational costs every year. I know the Passive House course did a study in some public housing in Germany, and they did all these assessments at the start of the project to work out whether they should build public housing to Passive House standards. And I think it paid back within 3 years, 4 years, compared to the huge cost of energy bills that would be accrued over the lifetime of a building. The standards for higher quality construction are coming in. It's quite ironic because the current standards and previous standards for assessment of the NatHERS actually rate passive house really low, because the way the rating system's set up it presumes a certain type of construction, and it doesn't presume something as complex as passive house, where everything is very carefully considered. So there's been a lot of lobbying, which has been corrected in the soon to be released NCC and NatHERS, that actually tries to balance out some of the different ways of building, such as passive house. I don't know if that answered your question, Mary, sorry.
Can I ask for residential? What does it mean? So what bulk insulation rating do you have in the walls and the ceiling and so on? And then for the Cows Cultural Centre, does anybody know what's done with that? So a larger building, is it R23 in the ceiling, or
well, that's the thing,
what
Bernie.
does it mean?
It's not just one element. Literally, it's a pity I don't have the passive house sheet open, but you actually calculate the buildup of every wall, and its R values, its U values, its thermal bridging, and it calculates this across 40 pages of spreadsheets. So you can go with a lower R value for your insulation, but you're going to have to up your windows, and you have to balance out in other areas of the building. So there's not one answer. You're not looking for one thing in any part of the building. It's every part of the building balancing out to get that 0.6 maximum air changes per hour. So it's a very complex document, but as they say, it's putting the time in before it's built in the design process to make sure it will perform. And then when it's built, it is tested to ensure it does perform as predicted, which doesn't happen in any other standard in the world, as far as I'm aware.
In terms of getting it implemented, though, so for the Coalition for Community Energy a few years ago, it cropped up there that it's actually been done in the ACT. I don't know if it's been spread anywhere else, but if you're building a house, to get your completion certificate, and or if you're a landlord and renting it out to tenants, you must have an energy efficiency test done on that building. So you do the air pressurized thing and look at it and do the thermal camera thing. And is there any progress with that in Victoria?
I'm not sure, to be honest. David, is this where I say you had your hand up, and do you want to comment?
well, no, I had a question about something else, but I can't quite comment on that. I think there's a lot of room to move and improve in that space in terms of residential, business, industry with a lot of this sort of
stuff. Is it on the priority list anywhere to have a regulation like that people must have certificates?
Oh,
like a roadworthy.
Yeah, it's been talked about. I think there have been some things with the Victoria's climate change strategy that are coming in. I don't know if there are any further improvements beyond that in the plans, but that's certainly something we've been hearing a lot about. So with TELP, so I work in climate change and specifically climate change adaptation. And when we're developing our regional adaptation strategy, that's something that we were hearing was about that thermal comfort is very important. It's something that there are a lot of vulnerable people, low-income people that just don't have the means to be able to improve their properties. They have the want, but they don't, have the means and the resources. So there's a lot of things in terms of that space about supporting people to implement those sort of changes. And yeah, a lot of people still think there's more things that need to be done, more things that need to be set in either regulations or policy to be able to do that. So, and it's something I'm still happy to keep feeding up my line of managers and back through to our policy group as well, because it's not something that's going to sort itself out. You'll get some progress, but there'll need to probably be a little bit more movement in that sort of space.
So David, do you want to ask your question?
Well, yeah, so I was going to start off the question by saying I've got both a personal and a professional interest in this. The professional is, as I've probably said, is that, there's been a lot of comments that have come back through our development of the strategy about how important it is for thermal comfort. And you're outlining with the retrofit process that there are a lot of complexities in that. Is there and I guess probably what I'm thinking is there is it someone you can call and say, I want to retrofit my house to be more like a passive house to get as close to that certification as possible? Are there people who do that, like builders or I guess people like home handyman is kind of, for want of a
question. And I think that's where PassivHaus, let me answer this another way, which is I've been chatting a lot with Ian Southall. So I believe, I don't know all his official capacities, but I think he's with the Gippsland Climate Change Network. He's got the renewable energy demonstration trailer. And he's aware of a lot of people regionally who can do the pressure testing of the house. So passive houses, to get that air change per hour, are tested at both positive and negative 50 pascals air pressure. And that will then determine whether or not what the leakage rate is. So when I've been chatting with Ian, just casually inside conversations, there are ways you can improve, for instance, thermal comfort and air tightness, and have it tested with a pressure test, which is probably a lot simpler than going through a fully certified Enerfit retrofit with PassivHaus, inputting data, determining existing wall build-ups and that kind of thing. It's very complex and you never know. I mean, I work a lot in alterations and additions to houses as an architect, and even just a standard, not even high-performing, sustainable project. You never know what you're going to find in old buildings. We've found brick walls that are single skin at first floor and highly dangerous, that are sitting on loose bluestone footings, So what we have as an existing building, I guess, heritage in Australia is really hard to predict. And basically, I think we are probably linked in with New Zealand in having really poorly performing homes. I know I visited a friend who was living in Wellington, but she was from Germany, where they get -30. And she said she's never felt so cold as when she was in New Zealand, because our houses just aren't designed to be stable. And you could say it's because our climate's not that extreme, but we do find our climate is getting more extreme. But also, again, if you think of the Doctors for Climate, who are starting to equate human health and detrimental health with our poorly built buildings, let alone, I won't even get into off-gassing and toxic fumes and asbestos, and that we still use products like MDF that are banned in other countries because of the glues that are inside them. And there's just so many things that we need to do. But I think, again, there's no short answer, but sorry, David, I think at the moment, there's so few PassivHaus people in Australia. I was reading this morning, actually, somewhere in the book, it was 3 years ago, there were like 60 passive house designers. Now there's 260 in all of Australia. So it's growing rapidly, and we're hoping it is going to be a huge rapid growth in the people who are equipped to deliver passive house solutions. And I think if we look at things like the Declare movement, so the Australian architects declare a climate and biodiversity emergency. Likewise, builders declare, planners declare. I hosted a series of talks last year for Open House Melbourne, where we brought all of these Declare movements together and had a construction declares think tank. But really, I think that's what we need. We need people coming together and making it easy. And that's really hard to do one by one, which is why I'm sort of really excited to be in TRPI and starting to try and bring people together so that we can actually share our information and our knowledge and find the easy way. So it's not every single person out there looking for who can put their hand up to help, if that makes any sense.
Zoe, could I just come in there and just maybe it might to a couple of people's questions. TRPI has a vision to develop a demonstration site, and Zoe might want to speak to this again in a minute. But the goal is to be able to showcase retrofitting and what's possible, and we're looking towards some sort of a location possibly at Gap Road at the new circular economy transfer station there, to look at having a site where the sort of things Zoe's talked about, which are different materials, different ways of retrofitting to upgrade existing housing stock. Zoe, do you want to speak a little bit about that? This is still in the vision stage, everybody, but it, from a couple of people's questions, it's definitely something people want to know more about and want to see, to be up close and personal with it. So, Zoe, do you want to comment on that?
Yeah, definitely. So we're really keen to take an existing building, maybe it's a relocatable building, something that is existing and doesn't perform very well, and put it somewhere that people can come and touch and feel and engage with it, have sensors in it so that we can monitor it over time, record the difference as compared to that building before it's been changed. And then we want to put the hard work into basically upgrading it and testing how it performs, checking how far you have to go to actually make it, whether it's fully passive house or whether it's just a high performing building that used to be a non-performing building. So we want to do the hard yards really and all the research and get this test building, so then we can implement that knowledge, implement those materials, and also get some local manufacturing. We can upskill people, do education programs, get tradies who are equipped to do all of this and have the knowledge and expertise to do it. And also consultants, whether it's architects, building designers, whoever, so that we do have that on call for people who want to do these kind of things. So that's one small vision. I also have a personal vision, which is perhaps a little lengthy to explain here, but more related to caring for land on farms and regenerative farming practices, that we actually could have sort of prefabricated small passive houses that can sit on farms and assist those farmers to care for land, almost like a more formal woofing system, I guess, so that you actually get high performing homes that help solve housing affordability issues, could be on a limited tenure or a lease or a who knows what. But essentially it's allowing people to sort of micro farm or do share farming. And again, it increases rapidly our ability to look at healing land and regenerative practices. Because I think somewhere in between, we've got to balance our human built environment and our natural environment. And I see that kind of vision, again, that's my personal vision, but I see that as helping to look at that.
I'll sign up to be an apprentice on those 2 vision projects you just said. That's amazing.
Oh, great.
How much knowledge can be transferred on that, and I can learn and share along the way.
Brilliant.
And in the chat, I just said, is there someone that TRPI can recommend who can come out and do our home audits to help us? There's too much information and I'm overwhelmed, don't know where to start modifying our little beach house as well. Is there anyone you can recommend?
Well, who comes to mind is, and Mary, I think I saw you about to speak as well, but I know John Coulter from the Energy Innovation Co-op. I should say the Energy Innovation Co-op, who are one of our member organisations and that we work very closely with, have a lot more, I guess, practical programs than TRPI, such as helping community centres put solar on roofs and doing energy audits and that sort of thing. Mary, do you know specifically?
Yes, so possibly what we can do, Christine, is we'll aim to get that up on the TRPI website. But there are energy auditors who are recommended, and I'm pretty sure it's through the Bass Coast Climate Action Network, who have a number of energy auditors who come to your house. It's it's a reasonable fee. We had our own house audited this year and found it extremely helpful. So if I can leave it with you, that we'll have those. There's a number of people that are recommended, and we'll get that information up.
Thank you so much. That would be awesome.
Okay. We're nearly done, Zoe, are we?
We are nearly done. We've gone over time, but I suspect from the interest in the discussion that we could almost run some more sessions in the future on these kind of topics. And this is where it can get confusing because there are so many systems and measurement procedures out there. So a star rating is the NatHERS system, which again rated PassivHaus very lowly. But then on a performance standard, when it's tested, PassivHaus performs incredibly high, and perhaps takes into account things that aren't included in the star system, such as the actual, I want to call it the ecological system of the house. So mold growth, stable temperatures, balanced temperature floor to ceiling, all this kind of stuff. So I guess it depends. It's that question of how much of a purist are you? How much do you care about the environment of your building? And I guess as an architect, I care very much because I deal with old buildings that don't perform well. And I see, rotted out, moldy, harmful materials that might have asbestos components in them. And to me, I think we've got to do better. But there are also very low-tech systems available that might not even be PassivHaus. For instance, hemp as a product is phenomenal and can be grown in 6 months and cultivated into basically a rammed earth wall that can be made by community on site and takes 20 minutes to set and is part of quite a beautiful team building sort of, earth project. So there's so many different ways to build. And I think that's why I'm saying I'm not trying to sell PassivHaus. It's just a highly efficient, resilient building type that is very carefully, tested before it's even built. Whereas something else that might be more of an earthship kind of house is something that you can't verify or test until after it's completed. And then it's a matter of just, monitoring its performance and seeing if it does perform the way you think it will. So just different approaches, really. And I'm not saying one is the answer over the other, but I think we need to consider carefully the way that we do build to make sure what we're building now isn't going to have to be renovated in 2, 5, 10 years because it's just not performing and it's not resilient. And we're already seeing when we're sizing things like gutters, rainwater heads in architecture, you use all of the stats and figures for like 1 in 100-year storm water quantities, but we're seeing the 1 in 100-year storms that we used to design for are happening every 5 years. And soon they're going to be happening every 1 year. So if we don't adapt the way we build, from everything in terms of sizing our gutters through to allowing for flood inundation and cyclonic events, we're just not thinking ahead. And as I was telling my students at Monash, buildings we build today are going to be standing in 20 years. We're going to be seeing extreme weather conditions. So what we're building right now has to be better. That's just as an architect, I'm moving away from actual architecture and almost into pure advocacy now, just because one project might take me 3 years, and it's like I can't do that one project by one project by one project. I've just got to share info and try and get everyone building better right now.
If I could just say, I'm sure on behalf of us all listening today, I'd like to thank Zoe for her presentation today. It was terrific, great insights. We've got a wonderful mind here in Zoe Guy here in Bass Coast, and she's leading the way in many things to do with moving us all towards totally renewable Phillip Island. So Zoe, if you're happy, we may wrap it up there. And I'd like to thank everybody. I'm Mary Whelan, Chair of Totally Renewable Phillip Island, and thank you all for attending and for your questions. And through the TRPI website, if you have anything you want to ask, if you've got any suggestions, we have thought a lot about doing extra sessions, or and we're looking to progress towards this demonstration site. That'll be one of our goals into next year. So thanks again, and we hope to hear from you soon. Thank you, Zoe.
Thank you so much. That's wonderful.
Thanks,
Thank you.
everyone.
Bye-bye. Bye-bye.